I guess as the other people join us, we'll go ahead and jump right into it. Well, first of all, good afternoon, everyone, and welcome to the ACADIA at special focus session for the ACSA 100 conference. I'd like to start off describing exactly what an ACADIA at event is and why they exist, and why this one is of particular significance. ACADIA is the Association for Computer-Aided Design and Architecture. It was formed in the early 1980s by a group of like-minded innovators and thinkers, including Bill Mitchell and Chuck Eastman. Its mission is facilitating communication and critical thinking regarding the use of computers in architecture, planning, and building science. A particular focus is education and the software, hardware, and pedagogy involved in education. The organization is also committed to research and the development of computer aids that enhance design creativity rather than simply production. And that aim is focused specifically at the construction of humane physical environments. Membership of ACADIA is open to educators, students, and professionals who believe in the need for a particular education that in the area of computer-aided design are willing to contribute time and energy to its development. Members come from all over the world, including the United States, Canada, Latin America, Europe, the Middle East, and the Pacific Rim, and include professional design firms and software industry. ACADIA at events offer an integrated method of critically positioning its members in areas where they can demonstrate impact and inform larger groups of educators. Partnering with ACSA over the last 2 years has fostered that mission and has reestablished ties between organizations. Because ACADIA focuses its education and research, most of its members are also affiliated with colleges and universities. This year's ACADIA at session builds upon a fantastic 2-day charrette sponsored by ACADIA, ACSA, and Objet. The 2-day event took place at the Objet headquarters in Billerica, Massachusetts, and I'd like to offer special thanks and sincere gratitude to Jerry Barbarian, Shelley Lenore, Leah Kaplan, Lisa Hannon, Bruce Bradshaw, and countless others from Objet who assisted us for their tireless efforts not only to facilitate this exchange, but in documenting the workshop, cleaning the models, and for providing an invaluable learning experience. The participants for this year's event included David Beach, an assistant professor at Drury University, Jennifer Buck, product designer at Lavallee, Mark Cabrina, assistant professor at California Polytechnic Institute or State University, Wendy Cox, Associate Professor at Norwich University, Derek Eggers, Director of the Viz Center at the University of Kentucky, Bassem Mohammed, a PhD candidate, James Hayes, a PhD student at Carleton Immersive Environment and Media Studio, Mustafa Khalifa, a PhD researcher at the University of Camerino, Italy, Nicole Kolptik of Drexel University, Amanda Kroll, a student at the University of Houston, Rigo Moreno, a student at the University of Houston, Bartolome Zapata, assistant professor of architecture at Keene State College, Emmanuel Vermiso, assistant professor at Florida Atlantic University, Andrew Verana, a visiting assistant professor and research assistant professor at the University of Houston, and Aaron Temkin, the dean of Norwich University and the president of ACADIA. This special focus session will discuss the pedagogical implications of the workshop. I'll serve as the moderator for this session to frame the conceptual underpinnings of the workshop as part of an embedded and participatory and replicable art-to-part curriculum developed by the workshop team leaders. So the session was, wow, that's horrible. Gil Akos, Kyle Miller, myself, Greg Luhan, Ronnie Parsons, and Andrew Payne. So as we're discussing the overall vision of the project that we did at Billerica, what we ended up developing was a synthetic landscape that's on display downstairs in the exhibit hall. We went over, the whole purpose of this workshop was to combine, treat it really as a design studio to allow these students and workshop attendees to participate with a team of expert consultants to hone their digital and prototyping skills, to experiment with a range of digital production tools, and to design and fabricate a unique set of components that negotiates a material gradient field across a design field condition. So what I'm showing you here will explain a little bit more as we go through today's process. We developed a 3D printed 30-inch by 120-inch 30-tile linearly connected field condition that was collaboratively designed and fabricated by the team leaders. The synthetic landscape articulates a general material gradient between hard and soft, between horizontal and vertical, that ultimately allows for an adaptive porosity across the site. The synthetic landscape forms both the digital and physical basis of the participant's design response. Described as an elegant, exquisite corpse, this landscape form allows each workshop participant to design a particular material condition that would respond to and then negotiate either above or below or adjacent to this datum. We called this iterating or aligning iteration with design fabrication. It's a way of aligning knowledge information, knowledge integration, and knowledge exchange within the design thinking process. Working across multiple software platforms, workshop participants developed a series of iterative prototypes that negotiated this material gradient field, exploring texture, form, perforation, and light. And these prototypes range from locally to globally defined adaptations, working collaboratively and individually to come up with a design scheme. The results of the workshop are on exhibit now at the Boston Park Plaza Hotel. And it will be formally presented today by the workshop team leaders through a video, and then will be part of a traveling exhibition that ideally will circulate North America in 2012, and then ultimately find a resting place in San Francisco. So these are kind of our thoughts about where this could go, but if anybody else wants to exhibit at their home institution, it'd be fantastic and well received. I'd like to also plug here synthetic digital ecologies at the ACADIA 2012 event in San Francisco, October 18th to 21st. There should be an advertisement for this in your bags. And I'd like to call your particular attention to the call for abstracts, which are due March 5th, but the call for full papers, works in progress, projects, and blind peer review is April 10th. So I guess what we could do is start with the video, and then we'll go from there.
So that's this should be in that folder.
Which one?
Yeah.
Fantastic. So along with the digital artifacts that are downstairs on exhibit in the exhibit hall, we explored a whole range of tools from Grasshopper to Weaverbird, and we not only created the forms with it, but we asked the students to use it to generate their animations. And this is what you're looking at now. We met in the lobby of the hotel at 8 o'clock in the morning. We got to Bellarica at 9 a.m. We started work about 9:30. We worked from 9:30 through lunch to develop a prototype, 2 inches, to understand how to work with the Objet machines. We then had a sequence of machine elements that were prototyped for us at 2 inches by 2 inches. And then we learned from that the output of those materials to understand how we can design further to integrate with our synthetic landscape. We started that design about 4:30 or 5 o'clock in the afternoon, worked through dinner, and then sent everything off to the plotter by 10 o'clock in the evening. Next morning, we came back, and it was like watching childbirth. All your machines were rapidly working for us, developing our prototypes. We then, with Objet, we cleaned them, had them organize them for us. and then we installed them on the landscape for the first time, just testing them out. Then we worked in the afternoon to visualize these, and the animations that you're looking at is about an hour of work, or an hour and a half of work, and then we presented them, put them together in this video, and here we are. So it took us about 45 minutes to install the installation downstairs, 300 LEDs, 300 batteries, 30 tiles, 360 acrylic posts, and 20 objects that were floating on that landscape. So the way that I'm going to moderate this session today, I'm going to have Andy Payne come up and present his work, and then Kyle Miller, and then Piet Meijs. Okay, so Andy.
All right, thank you. Thanks, Greg. And we were asked to sort of, for this panel discussion, to briefly present our work and what we've been researching, and then try to relate that, what we've done, into the context of what we worked at for the last 2 days with Objet and with this workshop. So I'll do my best to try to explain some of the stuff that I've been working on in about 5 minutes. So some of the stuff that I've been working on over the last year or two is a special set of software called Firefly, which sort of bridges the gap between the physical world and the digital world. It's a plugin specifically for Grasshopper, and a lot of the participants got to work with Grasshopper and Rhino during the workshop. And so while we didn't have enough time to actually explore some of the stuff with Firefly, I'd like to show some of this stuff and then see how it might be pursued in the future at perhaps another workshop. So what Firefly does is it allows us to basically access real-time live information from the physical world inside a 3D parametric digital environment. So for example, you can actually access analog sensors or digital sensors. You can do light sensors, distance sensors. You can get information from internet feeds or webcams or the Kinect, for example. And all of those can actually then inform, they can become design parameters in the Grasshopper interface. Those can also be fed back out and control actuators such as lights or servos or motors or valves or anything like that. So what you get is this sort of new feedback system where you can control actuators through Grasshopper parameters, or you can control your your digital prototype with real-time live sensors or any of the combination between those. What it also enables you to do is to move away from the traditional method of actually writing code, so this serial representation that we're used to with writing code for interactive projects with like an Arduino, to this more spatial representation. And so it becomes a sort of black box, but it becomes easier a little bit to allow beginners to actually get into the interface and working with this sort of interactive prototyping environment. So to give you a feel for what Firefly does, let's see if this is going to play. You'd think it would if on my own computer. All right, that one's not going to play. We'll play this one. So what it allows you to do is take real-time information from like a sensor, in this case just blowing on a microphone, for example, to actually simulate a wind vector inside a 3D environment. So it's the first time we're actually getting to take live information and control it in a three-dimensional environment. Now this has existed in other software packages out there, like processing and other visual programming languages out there. So this isn't necessarily entirely new, but it is one of the first examples where we actually get to control 3D information in a three-dimensional modeling environment. So doing something like this is the Kinect, which can track your skeleton as you move around, becomes trivial to actually control lights or motors because I'm actually just extracting the height of my hand, which is actually a point in space. And so this becomes really easy to control, say, a motor or a light. And these are really simple examples. I'll try to get into a little bit more rigorous examples in just a second. But the idea is to show you that we can start to do live simulations in a parametric modeling environment as well as control physical actuators. So where might some of this actually be applied? And so I began thinking of one project that came to mind, and again, I'm trying to be brief. So how can architects engage robotic prototyping, which has sort of become increasingly popular over the last few years, as evidenced by the number of papers presented at ACADIA. So what's interesting about robotic fabrication is that it's not task-specific. You can do additive and subtractive routines. But as an architect trying to approach this, it's a little daunting because the manufacturing know-how takes a number of years to actually perfect, as well as the scripting knowledge that might come with that to back that up. So what I wanted to do was actually develop some sort of tool, some sort of device that might facilitate the robotic fabrication process, and something drawing upon the past of what architects are already used to, which is, say, drawing tools, for example, which they're already used to in terms of developing their design ideas. So the concept is very simple. It's just starting with one of the any model, but in this case I was using the ABB IRB robot, 6-axis robot, and essentially you extract the joint and axis configurations and then design a tangible controller around those conditions. What's nice about this, the way this is designed, is that the designer immediately understands that as they move the tangible controller around, the robot will perform those same motions. And you can get a real-time simulation. Come on. All right. Let's.
You got time. You don't have to rush.
So you can get a real-time preview of the robotic simulation moving in Grasshopper as you move this tangible controller around. So what normally, the normal process of creating tool paths, which normally goes through the process of using industry-specific software such as Robot Studio or Mastercam, to create organic tool paths like this could take hours for a manufacturing consultant. In this case, as you're doing this in a matter of seconds, so it becomes trivial. And because this is all part of the actual Rhino and parametric environment, this can be expanded upon because now you can perform other geometric manipulations with the robot. And I'm going to just move to the next one because it looks like my videos aren't wanting to play. So at the same time, we can take this and also stream this directly to the physical robot, right? So we can actually have a real-time output going from direct tangible input to direct physical output by the robotic controller. So the idea is to not really come up to, it was a proof of concept to basically come up with a more streamlined approach for architects to get to engage robotic fabrication using this new interactive prototyping platform called Firefly. All right. So, bringing it back into context, how can we actually then bring this back into what we were talking about in terms of the workshop? So unfortunately, as I said, time being one of the primary constraints, we didn't have enough time to actually get into programming the LEDs underneath this synthetic landscape that was designed. But I think what's a really interesting potential combining this in the future is the idea of 3D printing electronics. And this isn't necessarily new. This has been around for a while. This is an example done by the University of Illinois at Urbana-Champaign of a 3D printed antenna. That you can see, and then there's newer technologies being developed by Thin Film Electronics and PARC, which is formerly Xerox PARC, which is 3D printing semiconductors and transistors on flexible materials such as this. As well as this can be done, this is an example actually done a year prior of actually 3D printing transistors and memory on using a MakerBot, so using silver inks. To print these on flexible materials. So I think there's a really interesting potential here where the design, what we've been talking about in the workshop, which is sort of this design production of mechanical parts and these 3D printed objects, to start to embed some of this electronics and intelligence into it. And then with the same software, you can also begin to start to control the behavior of the product as well. So I think it's what's really interesting for the future is for architects to begin to start questioning these ideas of how do we want our objects to behave, because they're going to start to be embedded in more and more of our objects around us. So how do we start to engage that as educators and as academics and professionals? Okay, thank you so much.
Okay, thanks Greg for inviting me to be a part of this special focus session, and thanks to all the sponsors that enabled us to run this workshop for the past few days. What I'd like to do today in my allotted 10 minutes is try and show 3 projects. One that was done quite some time ago, and 2 that are basically a further development of some of the issues that arose in that 3rd project. And maybe before I get into it, a lot of my more recent efforts have been focused on basically employing digital design, parametric design, and then digital fabrication in a way that increases performance across the board. So in terms of controlling environmental issues, cost calculation, constructability, and things of this nature, and really allowing then those processes to be front-loaded and allowing iteration within the design at a more qualitative level to become prioritized. So the first project I'd like to show is a project that I did while I was studying at UCLA. It was a technology seminar that adopted the process of superforming aluminum to create facade panels. And the premise of the course was that each group could only basically use one mold, and which basically then allows you one facade panel. And so what we did already was to divide the mold into 3 parts, and basically through a kind of typical male forming process of this superformed aluminum, we could get 3 types of panels, which would yield a variation across the wall, or a kind of larger field effect that corresponds to the incremental change of the facade panel. My group sought to take it a little bit further and said, actually, how can we introduce mass customization of these panels into the design process to create an even kind of micro-scaled field effect across the facade in this case. And so we looked at the technology specifically and began to kind of zoom into how the variable pressures could be controlled locally to create more localized deformations or formations within each one of these panels. Which would yield, again, a micro field effect at the scale of the panel that would allow for larger either vector-based or raster-based images to occur across the facade. And then even in this one, a similar image later will tie back to this, where rethinking how construction documentation would occur when you can't, you're controlling something like pressure, and thinking about pressure registration points rather than more conventional plans and sections or details. This was then the end result of that facade panel. A very simple connection system that would allow these panels to lock in place, and then a few photos from the final prototype. The next project then scaled this up a little bit. This was a competition that occurred last year. I finally finished it up recently. It was for the recladding of the Pushinsky Cinema in Russia. And basically a kind of continued interest in the field effects that may emerge over the expanse of a facade, which would be a bit more void of any cognitive reference and appear actually to other senses rather than the mind. I'll get into that in a second as well. But basically then introducing a more dynamic variation of a panel system that would be arrayed across a facade to give this more fleeting visual effect rather than a more static, fixed point of reference, or even a facade that may act as a signifier and reference something other than itself. So in this case here, it's really using more inherent or more ingredients that are more inherent to architecture, such as color, texture, pattern, translucency, to be the most celebrated parts of the architectural design, rather than things that they may reference. Again, then attempting to optimize the amount of panel types that would be arrayed across this facade, and also thinking about how those panels would get identified attached to a substrate, but then allow for that variation to occur quite seamlessly across the entire field. This then was the result of that, and a night shot. So moving forward then, I think that my take on my own criticism of the last two projects that I presented are that they are merely superficial in the fact that they cannot perform other than virtually or visually. And so I wanted to continue exploring some of these things, but in a way that some of those variables, such as texture and color and pattern, can become more performative in a much more objective way and still maintain this kind of visual intensity across the field. So this is a current research project of mine that I've basically stayed in the realm of designing facades in an attempt to kind of be consistent about some of the things that I'm attempting to study. And for me, this was a way to synthesize all the things I'm interested in and bring them together through a singular building component, one which I think basically has the most visual impact in terms of the scale, how the building presents itself to the city and how it becomes identified in a larger cityscape. But at the same time, a building component that is most critical to a building's performance criteria in terms of environmental considerations and even more sustainable features. And so for me, it's really attempting to balance that more objective set of parameters with a more theoretical or conceptual approach that comes back to, again, things that for me were introduced at UCLA in terms of thinking about the discourse of affect, contemporary ornamentation, and just the overall kind of ideas behind supermodern architecture and reacting to postmodern architecture, reacting against postmodern architecture. And then bringing these together through more sophisticated use of software and hardware to synthesize all these ideas in a way that they perform not only technically and objectively, but more virtually and visually. And then again, like thinking about which platforms I may start to use to basically achieve these larger goals, rather than simply dive into one and be limited. So for me, it's also about starting to branch out a bit, finding platforms that can assist me in the qualitative and the quantitative evaluation of these building components, and finding the most seamless way to integrate everything across the board. So again, I've isolated the building component as a facade, the facade as a building component that I'd like to explore these ideas through, and basically set up a parametric file that can negotiate all of these different parameters in a way to balance those more, again, subjective and objective criteria. And so thinking about just material usage, but then pairing that with the overall desired visual effect, paired again with desired daylighting issues that may occur based upon the program that exists inside the structure, as well as direct solar gain, either controlling that or denying that depending on solar orientation and, again, desired penetration of those elements relative to the program that exists behind them. And then going back to the overall kind of more visual field effect that is created relative to the local control of the objective criteria that need to be met in order to allow the project to become truly performative. Linking that into Excel to really have real-time cost calculations of raw materials. For me, this is very, very basic at this point in terms of a quantitative analysis, but that's the type of thing I'd like to get more into in terms of really being able to kind of front-load the programming of all of those aspects and allowing the design to be iterative in such a way that those more objective criteria can always be checked or maintained throughout the design process. So this is the kind of current state of the project right now, kind of mass customized facade unit. Actually, the frame itself would be repetitive, and then the infill and then the glazing would be the components that become more unique relative to the overall panel, but still abiding by the overall performance criteria that were set up at the beginning of the design task. Thank you. everyone. My name is Piet Meijs. I was here, it was suggested to me by Objet that I participated in this because I work for Rietveld Architects in New York, and we have been using Objet printers for 4 years now. We have one in our office, and we have our own way of working with it, and it's pretty unique. We haven't found any other office that uses it the way we do. And the people from Objet suggested that I participated with the workshop led by Greg to see if I could teach them something or that they could teach me something. Turned out that they taught me more than I did them, so thanks for that, Greg. So my presentation is a lot shorter than these guys because I haven't done any research work recently. So I'll use my introduction to show a little bit how the projects that we do and how we use the Objet printer. I think what's important to note is that what we did during the workshop yesterday and the day before is that there was an approach from a research standpoint. What can the software do and what can the Objet or the rapid prototyping technology do with that? Whereas in an office, we have a much more practical approach. We need to represent something more realistically that we use to communicate our designs to the client. So this is one project. It's actually built next to the Technical University in Delft. Some people might know it. It's in the Netherlands. So we have a wide variety of projects that we do in a wide field. So we do office buildings. On the top right, we have a nursing home, townhouses. We have residential towers. So this is the part of the rapid prototyping that we do in our office. We have, as mentioned before, an Objet printer, an Eden 350. What I thought was very interesting for me to learn during the workshop was that because it was such a research approach, was that the proportions were much more important than the scale of things. It was unclear to me if we were working on a, let's say, a furniture scale, a building scale, an urban scale, or even bigger than that. In our office, we deal with the exact opposite. Scale is very important to us. So when we approach a project, we study it on various scales. So we make various models to communicate different things. And I always like to put numbers on it. So a 1 to 1,000 scale is really to communicate how the mass of the building volume sits within the context of its surroundings. Then the next scale, 1 to 500, is more of a drafting scale. 1 to 400 worked better for us in the models. But then you go look at the design more on a building level. So open versus closed, the plasticity of the architecture, and so on, and communicate that with the model. The rapid prototyping technology allows you to do many fun things. On the top left, for example, you can easily do a section, and the biggest advantage is that you can also make copies of the same model and iterations. If you use hand-built model with cardboard, every time you do an iteration of a model, you start from scratch, whereas with rapid prototyping, you can literally just adjust the computer model, hit print, and you have the new model. We're slowly starting to look at new approaches, how we can use the technology. We're starting to actually prototype one-to-one now. The light fixture on the left was for a private client who wanted to have 22 of these lamps custom made, and it was totally worth it for him to first do a prototype.
But where we're now is that we have this new technology in-house, we have the capability, and we want to do more with it than just replacing the hand-built cardboard models, where we're now looking at new ways of utilizing the technology. So the workshop that I was allowed to attend to was very helpful to that. So thank you, Greg. That was my introduction. Thanks.
Yeah. That's fine. You want to just put the first image up?
Yeah. You want to sit on this? Did you want to sit? All right. So I noticed that while we were presenting that some of the workshop participants came in, and also our sponsors. So maybe I can ask them to stand up and be heard, be seen.
Right.
Fantastic. Fantastic. So before you leave, Andrew, you might want to watch your video. I didn't think you would. All right, but, and again, so Shelley, you weren't here for your introduction, but I'll just say thank you again to Objet for such fantastic sponsorship and assistance. So I'd like to call out very specifically Jerry Barbarian, Shelley Lenore, Leah Kaplan, Lisa Hannon, Bruce Bradshaw, and countless others that helped facilitate the workshop. I wanted to go through the video one more time, and then I wanted to talk very specifically about some of the pedagogical implications of the project, and maybe make some links forward as well as backward, because we find ourselves right now, especially at this conference, at a node that's in between both ends of those spectrum conditions. So why don't we go ahead and watch the video, and we'll come back in and we'll talk specifically about that. Fantastic. Cool. All right, so I'd just like to kick off the discussion with a question to the panel. and also open it up to discussion with the workshop participants. Some things that we've been talking about is the role of parametrics, the link to research, and the exploration of material gradients across a field condition. And what is really being explored in my mind through the workshop and the way that it was framed as we started thinking about the synthetic nature of architecture today was really in this concept of blending. And what was really interesting to see in that blended context was the pace of innovation. And I'd like to just describe a little bit, if you could, the active engagement of iteration, the pace of the exploration as seen through the lens of retooling, and the opportunity to engage at this level with workshop participants, some of which didn't know the programs and that we're working in a variety of scales. So maybe we can start off with that.
Sure. I mean, I think the kind of most beneficial aspect of employing those techniques and that means of not only design on the software side but on the hardware side is just the back and forth, and so the cyclical relationship of being in a virtual environment and then allowing that to become physical. You learn so much in the output of that, even if it is more of a kind of linear translation of those things relative to the tolerance of the output. But there were times throughout the workshop when those materials first came from the printer when you still found new things in them, even though they were basically exact replicas of what was produced in the virtual environment. And so I think the back and forth that enables allows for design to become smarter and more performative relative to the criteria that the more active parameters or parametric variables might account for and address. And so I think it's really the kind of constant back and forth that eliminates a linear, predictable nature of design and allows for interpretation and innovation to occur in a cyclical way very early on in the design process.
So just to build up on that, how important was it to print the physical artifact as compared to just exploring it on the screen?
Yeah, I mean, I would say it's incredibly important.
You can answer this.
What I think was very interesting is that if you're used to only designing a computer in a virtual environment, a lot of things are allowed. You can have elements just float into space. You can have the thinnest columns possible. But Gary Barbarian from Objet was also saying you can't make walls thinner than a certain dimension. You cannot make openings thinner than a certain dimension because we have to deal with support material that has to be removed. We have to deal with mechanical cleaning tools. So it was very interesting to see people look at their screen and all of a sudden think, oh no, this looks great, but it can't be printed. So that realization that it actually has to be built was probably very useful for people.
Yeah, I think the pace was an interesting element too, that we asked the participants to try to make a first test print within just a few hours of having arrived at Objet. For many people, some of the people who hadn't even opened Rhino ever in their life, so to actually generate a model that could be printed was a testament of how fast they could actually begin prototyping in the way we were trying to teach them. But at the same time, I think what was amazing is the openness and the pace. There wasn't enough time to necessarily dwell on any one topic. You just had to do, I think. And what was really interesting, I think, was people just by making certain intuitive decisions about what they wanted to try, and then test that. And then other people would say, oh, I see how fine-grained I could go. And what was amazing was to see how far we could push those machines, because some of the ones we thought, some of the test prints that I was sure wouldn't come out were some of the most amazing ones, because the tolerance level of the machines allowed such precision, which was really amazing.
Gary from Objet didn't even believe they would come out.
Yeah, actually, that was one of the most interesting things. He kept on throwing out parameters or limitations for the scales of the prints. You can't go below 0.009. You know, we were pushing boundaries. We were down to 0.003. And what changed is that instead of failing, the material, which was rigid, actually became more plastic and pliable. So the question, or the ability for elasticity to be experimented, again, I don't think we got that far in the workshop. It was only because we were able to actually interface with the materiality and the prints that there was another level that could have been embedded back into the parametrics had we stayed with that scale of object. Any comments from the workshop participants to build off of those concepts?
Yeah, I would agree. My project, the test task of mine was chastised for being it's going to break, and it worked. and in the gap between seeing the first test and when we started our next projects, I was actually not ambitious enough with my final. I felt like I could have gone much further, so I want to do it again. Really. and I
Shelley,
it's just sort of the iterative quality that you can start to do with it. That two passes didn't seem like nearly enough.
Andrew?
Oh, I think that the exploration of this tool is all about, well, in many kinds of fabrication, it's all about different levels of intricacy. But this is a different kind of intricacy that is I've never seen, sort of achieved on this level, where the sort of thinness and the kind of delicacy of things could be explored, in a kind of scaleless environment on the screen, and then it's like comes out and it has all the kind of intricacies and convolutions that were in the model, and that was kind of a eureka moment. We in our practice we work with fabrication on much larger scales, but intricacy in that case is very important as well in terms of but it's always about how things are coming together, how something meets the ground, and what are you doing in terms of kind of setting up a scenario where you can replicate the same accuracy that you have on the screen or in a shop condition, and create that scenario on the site when you're putting things in installing things. So the software allows for an intricacy on a kind of on that scale, and then to see it on this scale is even with playing out in a different way was amazing. I mean, there's a kind of an appearance of material differentiation with the different colors and things, but at the end it's all kind of the same stuff. So as this technology develops more, how it interfaces with other materials, whether you're printing parts that then interface with parts that are cut in more conventional means or milled metal parts. I mean, printing metal is now possible and all that. So it'll be really interesting. I mean, we have colleagues, Ron Real, who's out on the West Coast, and you know him, doing really amazing things with large-scale 3D printing, printing concrete, actually printing earthen materials, ceramics, and then firing these things, and then even talking about printing organic material, bone, and these things. So as we develop these things, and I'd like to attend if I could, I think it's on the same time as another session I'm on. So it's the composite aspect. How can you begin to print composites, different sort of densities of material? Maybe they're the same. There's the same sort of material that's being placed, but through another admixture, you can provide a different sort of material properties. Like the same way you lay rebar into concrete, something works better in tension, and you begin to combine these things in different ways. So I would challenge the makers of these machines to begin to think, work with architects, and get away from the material homogeneity of it. And it's not necessarily that you need to scale up, but we need to begin to think about these things so that these things can begin to perform not just as sort of on the prototyping scale, but begin to have structural possibilities.
Well, I think to build off of the prototyping idea, the idea in a design thinking context, of course, is to ideate and to design and then to fail fast, put it back through an iterative feedback loop, and then learn from that, and then ultimately come up with a prototype that can be tested and further evaluated. And I think that what we demonstrated, even in a very short amount of time, because really, I mean, the logistics of the workshop, we only produced for about 13 hours. The rest of the time was actually learning from the engagement and then representing some of those ideas and then rushing to install it as an exhibit space. But the idea of learning from these prototypes were really interesting, where the boundaries now, almost a blending between performance and representation, regardless of scale, because these things were something that could be learned from. I wonder if there's the next iterative loop of this is really about how the components actually join together. We developed that landscape as a way of kind of critically positioning so we can explore material gradients, learning from the datascape and then having it come through that image and then picking out points, grids, patterns. But what's the next iteration for you all in terms of the workshop leaders to take this technology or take that process and embed it back into the curriculum in schools? Is it something that would be more workshop based? Do we need a semester long of these classes to learn? Or Kyle, I know that in your own case, you're doing a series of workshops that are constantly building upon one another, and you're developing skill, you're developing expertise that then could be deployed. So maybe we can think about that.
Yeah, I mean, for my own interest is really to seek variability with a lot of these means of fabrication, and so the workshops that I've organized basically employ similar techniques, but with a drastically different output. And sometimes it's more analog, and sometimes it's more physical or digital. Sorry, digital. But I think it may be back to Andrew's point, where these machines basically become less homogeneous and a bit more performative relative to objective criteria, rather than simply with great precision replicating what is mostly known already in the digital environment. So for them to be able to take on structural characteristics relative to the variable materials that the machine can take on, I think is likely the next step, given that we've already moved from singular material machines to multiple material machines. And then I think a lot of it will then have to do with selecting materials that have certain inherent properties that allow them to become more performative. I think in terms of how they become implemented into the curriculum, I think it also is a nice way to quickly output potential designs, because as Pete identified, there's certain things that you take for granted in the digital environment that are made known when they become physical. And so I think for students to use the technology would allow them to have a better sense over some of the issues that are neglected when simply designing in a virtual space.
Yeah, to go back to your question as to which may be the best pedagogical method of actually exploring these ideas, I tend to reside on the fact that I think the workshop is sort of this perfect aspect to approach these types of things. We basically come up with a question, right, and then we seek to answer that in a very short amount of time. There's a very intense set of questions that we try to address, but ultimately what ends up happening is that the answers that you find end up seeding more and more questions. So I think the workshop, what's interesting is sort of the seed generator of more exploration down the road, but that it's basically a way to just implant or distill a whole series of very fine-grained questions that can then bleed over into more advanced research as you proceed. So I think what's interesting is that these workshops can gather a bunch of people from very diverse backgrounds and from all around the world, and have them come in for a very short amount of time and try to address these questions, but ultimately that actually then informs their research in another way as it grows. So I actually think the workshop format is a really nice way to actually explore some of these very specific questions, but then let that grow into other areas as they go back to their private institute or other institutions.
But even coupling like the kind of short bursts of taking on these techniques and exploring means of making that the participants never had access to before also allows them to rethink just the way that they might design.
Right, their approaches change.
Right. And so that's why I think coupling, as Andy's saying, that for me what's most important is the kind of afterlife of the task itself, and allowing that to ingrain itself into the mentality of the designer in a way that hopefully produces a more kind of optimal design process with respect to efficiency and kind of known parameters, working with the translation of virtual to physical.
Can you all speculate a little bit more about some of the analytic characteristics now that you developed this model and we've situated it in this landscape? Is the next iteration to forget those models, or is it to actively reimagine what the potentials of them could be?
Yeah, I think you're right. Everything you do always forms a basis to build upon. So we've explored the software, we've explored the possibilities of Grasshopper, Weaverbird. We made it physical through the Objet machine, and now I look at my own model and at the other models and immediately recognize the mistakes I made, and I saw great ideas that other people used in their models. So I think that it's just it puts a final point behind the workshop. It's like all this work that we did. You said 13 hours of production. That's all ended up in this model. So, and now we build upon that. We've learned from that, at least I did, and we'll take it to the next step from there. So the technology helps with that.
Yeah, because I think one of the biggest opportunities, rather than just treating it like a workshop to learn a software, I think the active engagement was actually to design. And in order to design, what we found is that you needed very little information in order to design. Right? That there was a conceptual level once you learned a technique. So can you start to bridge between these ideas of ideation, strategies and tactics, and then ideally leading up to an informed practice almost?
Yeah, I mean, for me, that's why I've tried to transcend just the simple techniques and allow them to actually contribute to a larger idea that might have to do more conceptually with theorizing contemporary ornamentation, or on the other end contributing to kind of the environmental performance of a facade system. But ultimately they come back to the sensibility that we actually employed in this workshop about parametric design and optimization, and the relationship between virtual and digital. And so I think that's, I mean, for me, that's where the kind of scaling up of that goes. It's not really about mastering a certain technique, but it's about being introduced to a range of techniques and a range of means of making, and then selectively employing those to achieve a greater good. And that's why, again, I think these workshops are really great, because they introduce participants, in this case, to things that they may not have been aware of, not just in terms of means of making, but also just the kind of ideas conceptually behind how you may design and how variation can occur within any design system.
I agree with Kyle. I spoke with Kyle earlier today, and I was talking to him about when my boss was my age. When he worked in his firm, his boss could actually explain to him how to make a drawing or a model. He knew how to operate a pencil and a ruler. Right now we're in a position where my boss actually does not know exactly how we produce certain elements on the computer. He knows that it exists, and only what we tell him that we can do is what he has available to him, which is very limiting. And so what Kyle was saying, to only be introduced to a certain software to know what the capabilities are is already a lot to have, because then when you have an architectural problem, you have an array of tools to say, well, I think that we can reach that goal with that tool. And hopefully the next generation, hopefully I'm included in that, now knows more of what's possible in the digital world to implement in the actual practice.
Aaron?
Yeah, we've been doing workshops at ACADIA for a while, and oftentimes, most often they've been software-based. You know, let's teach a bunch of people a piece of software, and those have always been very positive, and we had very positive results. And part of what was the inspiration of this was we've been talking about, you know, what if we talk about kind of start with a design question and not with the software, and see what comes of that. Now, of course, you know, there was some commonality in the software we're using. There was some commonality. We picked a thing to orbit around, which was the technology of printing, which is fantastic. But the fact is, the fact that people came with a very broad range of kind of interest and expertise, and kind of found a couple points of contact to work with, and the landscape is the thing that we responded to, I thought was really kind of had the result that
we were hoping for, which is to say, kind of what can we do that really brings a bunch of design expertise together, and let's focus on what the design expertise can produce. I really found, I think it's, if we think about this, we're all educators, about how we can bring this to the students. The fact that we all know that, given time, you can simulate nearly anything well in the computer, but we also know that there are a lot of things that are very slow to simulate well. I always tell students, don't get into the photorealistic, too early, because until you actually know what the mass and the structure and the nature of the thing is, don't worry about what color the wallpaper is. There are things like that, even just in doing this project, we're all trying to sort of guess at, how thick, how thin, where the center of gravity would be. Most of these things have point contacts in a fairly complex landscape environment, and we're relying on design kind of history and wisdom to make good value judgments about these things. But the fact that we could rapidly test things and could see that most of our instincts were right, where they're off, that one other iteration would have easily resolved it. I mean, just the sort of the learning curve that was witnessable between the first model and the second model, and I don't know that I expect everybody else had the same reaction I did, which is I saw what everybody else did and said, okay, if I were going to do this for another 12 hours, it'd be a significant improvement because of everything you can get out of physically holding it, see how it balances. I mean, it was, and seeing what was being done. I really think also that again, think about how I teach design, which often starts talking about the difference between the solid, the opaque, the translucent, and the transparent. Being able to actually do rapid prototyping where a young designer can immediately kind of address those three conditions actually kind of has opportunities to speed up the process in a really positive way. I mean, and I think being able to pull it outside and see what the shadows are doing is a much quicker, much more accurate way of understanding how light is affecting form than anything we can do with a digital simulation of light. I mean, that's perpetually a really difficult problem. So I really feel like the ability to get it out into the real world, not just was kind of palpably valuable to a bunch of seasoned designers, but would help make kind of, I'm rambling a little bit, but I really feel like one of the things that I struggle to teach is the difference between trying to get the draft perfect and trying to understand that an iterative process is about learning what you did wrong from the draft, not about trying to second guess perfection. And I really feel like we saw lots of ways of where you're getting just that out of this kind of feedback loop that we're using, which I think is fantastic.
Yes. Well, I would like to kind of give on what you were saying. I was the workshop participant, didn't know any software. I came in with an idea that I'm going to use SketchUp, and I probably would have, but all of a sudden it kind of became quite easy to learn that. And you did a really fantastic job explaining just the basic tools that I needed to actually control something, not just to put something on the screen and have fun with it, but really actually being able to control it. And then, yes, you're printing this one part that was teeny tiny and small, and came out of just a few simple moves, but being able to control it was kind of like this eureka moment. Wow, I can touch it, I can move it, I can really see how it feels and what it does. And then moving to the bigger model was even more interesting, but I didn't have this next level of skills that actually to expand on that model. So I think the workshop as a starting point was a fantastic idea for somebody who has no idea how to do this. And for students, this will be also something that I see would work quite well. But going to the next step, I think there will have to be a much more substantial learning and studying opportunity to improve upon that. And if you look at your models, the way you actually designed them, you would see that the gap between somebody who had no idea and just started, and then how you're expanding upon it. So I think it was a great experience.
He's talking about your model.
About my model? I think it's yours. Andrew, you were talking about the unique distinction between this type of workshop and other workshops. Can you kind of situate that in this context now?
Well, we've done workshops with TextFab, it's an organization of three individuals who are teaching at different locations in Texas, and we found within our own kind of academic environment that there was not probably the kind of critical mass we could achieve if we kind of joined forces on a regional level. So TexFab has given workshops and with a lot of Andy Payne's been there, and Ronnie and Gil have come down. We're doing another event here in San Antonio in April with Mark Bornez will be there as well teaching. And so we've done the route where we teach the software. We haven't had the kind of hands-on, project applied workshops yet. So that's one agenda I had for participating, was to kind of learn from this and figure out a way that we can apply that model to perhaps what we're doing. Because I think it's obvious that just the kind of images that come out of it, it's all kind of getting it's much more rich. It's much richer in those sense that it's not only internalized, but it's becoming externalizes some ideas. It picks a few tools to explore and then develops them very quickly. And so and then it would be interesting not just to say, okay, we're just going to use one machine, but then perhaps find a variety of kind of outcomes that a thing could take, and then look for a way that let the software perhaps drive the exploration, rather than just saying, okay, we're going to use this tool, so therefore we need to use a certain type of software that will do that. And so it would be interesting, like on the scalar level, to have kind of workshops that, like this one was working at kind of micro scale. It'd be interesting to have another workshop that was looking at the same sort of issues, but on a macro, kind of looking at a way you kind of build these types of geometries with another means of and methods of production at a different scale. So you would have, okay, here's a software tool, here's the kind of geometries that come out of it. Okay, you have one type of export and workflow process to go to a 3D printer. You have another process to go to a router or a laser cutter, right? So that would teach people, okay, there's a type, the software is agnostic, right? When you're still working in this environment, it doesn't know where you want to take it, it doesn't know what scale you're doing. So that would be interesting to kind of take that track and sort of study it at two sort of scalar outcomes, and kind of to see how you react to the types of geometries you're working with, depending on if you're making jewelry or you're making, like I made something I'm giving my wife to make a brooch out of for this thing, but then study it as kind of then, what are you doing when you're kind of working with sheet materials and maybe getting in some metal fabrication and stuff. So you're not creating a certain type of file that is making a solid file. You're going into kind of unfolding and kind of laminating systems and looking at beginning to kind of understand the sort of structural possibilities of how to keep it, and then kind of weigh the outcome and see which one is more, because we kept sort of pricing things as we like, what would this cost in print, and that having some economic aspect to it as well. I think like part of what we do at TexFab is we do competition. Like last year we did what was called Repeat. We had a competition. We put a call out. We had some of these people on our juries, and we had 100 people enter, and the sort of the money that people the registration generated basically funded the project. So the interest level and the kind of the wave of interest in the competition basically set the budget and set the scope of the project. So that's an interesting kind of thing. And then the winner was meant to understand that and work within that. So we're doing that again. We're having another competition called Applied. It will land at ACADIA, where this project will be exhibited. And so there's always a budget in mind. The shortlisted projects will have a set amount of money that they can work within. And rather than saying, okay, here's your 4x8 panel that you're cutting out of, there's other decisions to be made. So I think having some kind of economic implications in this would be, that you can print, but there was a size limitation, but
Sure.
It would be interesting to know, because we all want to come and start printing stuff, and then it's like, oh, I don't have
Well, I guess the big thing for me along those lines, because like I said, I think that we're at this point in the middle where there's an up and down stream. And there was definitely a condition where none of these models, with very few, I think mine was the only exception, the small scale one, that needed to be printed. Mm-hmm. Right? So there was a logic that said, if I don't print it, it's really not going to be possible to do. Mm-hmm. Right? Whereas some of the other smaller scale ones that were solid could easily have started off as, you know, a piece of stone and be whittled away, or to be a sheet good of metal and bent into form, right? And then you could have, you know, value or engineered it back and put it into the computer and then started off and use that as a departure point. Mm-hmm. Whereas I think the material explorations, especially linked to the fidelity of the machines, lent itself towards a different type of exploration that you really couldn't have prefigured. It really needed the link back to the software and to the analysis. And that's where I think that the next level of characteristic development has nothing to do specifically with the object, but it has to do with the techniques and strategies of moving forward, and then embedding that next level of complexity.
Yeah, I think in general, a lot of times when I teach, and I know Ronnie and Gil can kind of attest to this, that most of the time when we try to teach these workshops, it's more about teaching the logics about what it is you're trying to do, and formulating a set of constraints to explore those things. So as you mentioned, budget or the size limitations of the bed, you know, develop a workflow to work around that. But it really isn't necessarily about the object, because the goal is to teach the participants how to then go and take that knowledge and apply it in some other form or some other design down the road. But really it's about trying to distill the process into a certain set of teachable principles that you can teach. And I think that's a really interesting model that you brought up, is to kind of, how would you take the same form, or this software agnostic, and try to manufacture it in different methods, and what would the logics be to do, because obviously the constraints of 3D printing is very different from laser cutting or CNC milling. And so I think it would be really interesting to test that idea and see how you would try to take the same form potentially, or a similar type of form, and then try to replicate that, but see how that morphs over time given the different techniques of the tool.
Yeah. Like the landscape we created, okay, that was 3D printed, but if you took that kind of macro scale and like that was took one track through a fabrication, optimization, and material process, and in the 3D printing, those things kind of then met at the end.
Yeah, exactly.
The landscape we did was great. I mean, I think we should do it differently, but that would be, you know, perhaps there would be a way that those things came back together. You know.
Okay, let me ask two questions. One to the team leaders and one to the workshop participants. Workshop participants, we threw out a call. We said it's all about the art-to-part concepts. It's about material aggregation, material gradients. It's about part-to-whole relationships. It's about design, right? Regardless of software, and we knew that we had a hardware specific. First, what were your expectations going in, and then based upon those preconceived notions, the intersection to the workshop, and then your post-workshop thoughts. Pre, post, yes, Derek.
My expectations were a little uncertain. Typically in a workshop, I didn't expect us to have covered so much material in such a short period of time successfully. I mean, it was phenomenal. It honestly felt like half a semester or semester worth of coursework in 48 hours. And I think the value there is that you guys were all there, experts were all there together, and those of us that were learning from a variety of different backgrounds could share and exchange ideas and solve problems at a rate that would have been impossible if we had a day in between these little sessions and things. So the amount of accomplishment and learning gains was just blew me away. I mean, fit classic social cognitive learning theory of a group of learners together can accomplish more than individual learners given the same amount of time.
Manos? Wendy? Wendy?
So, back to that first question, for me, and I went back to like a historic methodology now, as I was sketching, right? And then maybe that drive with the with the sketching and to see that balance or lack of balance or eccentricity of how that works together would be another sort of interesting thing to fold into it. But I thought the having us do something really quick and small and print was great, you know, and it really reframed my whole perception of looking at these digital models, because as a professor now, this is how we do a desk grid. And when we look at something like that, we don't look at something physical really until way into the process. And so it's really given me a great just reframing, which is I think going to be really helpful.
Yeah, I was going to mention that our university, we're just now at the beginning stages of learning prototyping. And so to figure out the pedagogy of that, how I'm going to apply it to our curriculum, what's the best practice of doing that, was really important to kind of come in and get a Kickstarter on that and to make sure that, you know, I'm not getting a bunch of cereal box toys, you know, but having something that at least initially has some depth to it, and then we're going to add breadth to it as the program moves along with it.
Man,
I think I agree with that, and you know, what I take away with me living from the workshop is not necessarily what my expectations were, but I think it's much more I'll be different within a different framework. So I think it was a great and amazing kind of 48 hours, and based on the title of the workshop, focusing on the term synthetic, I think what would be amazing to see maybe in the next iteration, since this is what we kind of were discussing earlier, would be how could the components of each one of the participants could somehow be synthesized to create a global effect in a little slightly more integrated way, kind of like the substrate that you guys have created, which we used and was an amazing kind of layer for us to build upon. How could which I think brings into question what kind of constraints are given to us at the beginning of the workshop, and within our own table. I think we already had this discussion of maybe trying to make our prototypes kind of have adjacent edges or kind of be built next to each other, but then eventually everybody kind of pushed it away within its own constraints.
We don't have enough time.
So
Exactly.
to do so. So I think controlling us maybe a little more, as much as I enjoy the overall flexibility of the workshop. So I suppose it's always a kind of balance between how can you make it, keep it flexible, but also have kind of interesting controls. And I think that ties back to pedagogically, when you're relating not to experienced designers, but to students. I think that control becomes even more critical, because the students always need you to be told what to do. So maybe there's these two levels, one at a student level and the other one within a kind of architect or practitioner level, and how these two can kind of maybe mediate between one and the other.
For me, going to the next level, should you have another workshop like that, it would be very helpful to actually have the parameters available before the workshop, so I know at least in general what I will be working with, so I can prepare for that, and then I can spend more time on actually refining and studying, learning, and really exploring the software, as well as working with somebody else, how these objects can interact. That'll be the really desired option.
Yeah, I guess just to build upon that, there, if you had pre-primed the pump as you were suggesting, would it have been the same relationship back to the visualizations that Aaron was talking about, where now it becomes so fixed that it's no longer flexible? Or would you have been plastic in your kind of material learning concept? So you're asking actually for some of these tutorials to be kind of actively engaged first, so that way it's part of your making, then you bring it back in. Is that what you're?
Yes.
Okay.
I think it would be helpful for me, because then I can actually print the prototype quickly, the one that I brought with me, and really reflect upon it. So the going back and forth really happens at the onset of the project, and then we can really focus on working as participants together and collaborating more.
Okay.
Versus really, for me, spending more time on understanding how the software works and tweaking and looking for simple things.
Okay.
That kind of slow it down. But I mean, that'll be the next step.
Yeah. Sure.
I think the first step was amazing, and I'm pretty all about all that process.
Okay. And then to the workshop leaders, there's clearly a balance between pre-information, post-information, and then how you work. And I thought, first of all, thank you again for participating. This is, first of all, fantastic to work with Kyle and Andy and Gil and Ronnie on multiple cities, about 2 or 3 million emails over the course of the last 2 months. You can actually, it needs to be graphed. We need a grasshopper script for it that shows the density of emails, and then as we got closer to the workshop, and then this moment of convergence where there's almost been absolute silence, and I think it's the only way that we could sleep through the last night's lecture, and then coming in to now. I mean, it was really fantastic. So I appreciate that. But there's a balance that we're describing here, and there's also a consistent oscillation between the types of ideas that you want to explore, first of all, as educators, but also people that are kind of in that realm of the workshop that are instructors, which is different than the level of educator, right, as professor. And there's also another balance between the material research that you want to explore, the actuated skins, the ability to control and respond to environments, and then the ability to actually physically build it. So there's a kind of a morphology that really needs to be expressed here. And I think we're moving towards that in these types of workshops, and I like the next steps. I was always challenged by my professors like Olivia Ferrari to say, well, what next, now that you've done this? And if we have an opportunity to really question the role of a workshop as we move forward, my question would be is, what would that be? And what lessons did you learn from this one that we can bring forward?
Sure. Well, I mean, for me, and I agree with some of the comments, like to take it a step further and really allow the participants to exploit the capabilities in a much more meaningful way, whether it be interacting with their neighbors in a way that, again, capitalizes on the machines, but adds a kind of a more precise qualitative effect. But at the same time, there's a learning curve that's going to top off pretty quickly, and that's why workshops are meant to only last 2, 3, 4, 5 days, because at some point, then it just becomes a more elongated task that potentially gets watered down when additional parameters are introduced. So, I mean, for me, it really is about, again, going back to like the afterlife of these things and allowing the mentality and the logic, as Andy said, introduced in the workshops to contribute to much larger things. So already the workshops that I've done earlier in the term, the knowledge gained is filtering back into the design studios in a way that's very conducive to supporting the larger design tasks. So it's really about a kind of having a qualitative aspiration, but also balancing that with just competency of design and making.
Yeah, I would agree. I mean, there is this balance, and I would agree with what Kyle said, that you do want to set the parameters in such a way that you can really address the problem set forth in a very tight amount of time. Adding too many parameters, or adding too many different tools, or adding too many different topics can really just confuse everything and make it so much more difficult to actually produce something. At the same time, the length of time is still this important factor. I mean, I've actually taught 2-week workshops, which could I think have been done in say 3 or 4 days and gotten a similar output because of the way it's structured. You get this sort of intensity of energy that doesn't quite hold for those 2 weeks, as the same as sort of a 2 or 3 or 4 day event. And so I think that I mean, at the other side of this, I think what was really interesting is this was also a learning experience for all of us. Obviously we had certain skill sets in terms of the digital knowledge. I think for a fair bit of us, the 3D printing aspect was still relatively a new venture for even the instructors. So us actually seeing the printed parts for the first time, or when we were doing the prototypes, was really interesting. And then seeing how you guys responded to it was also interesting, because I think all of us were talking last night saying, I wish we had seen what they had done before, because we would have totally not done it differently, but we could have done so many other things because we did also know what was possible. And so I think it was a really good experience for the instructors, because seeing what the work that the students produced was so much more enlightening as well for how we might expand on that in the future. I also think what was good is that we tried to create an infrastructure that this thing could grow in different ways. So allowing people to plug in and look at one type of field condition might work in one way, but we could also host another 2-day workshop where you start to address these sort of intelligent adaptability or electronics embedded into these 3D printed objects, or so, you know, that could be a whole separate session that doesn't necessarily deal with the topics that we were looking at this time, but because of the flexibility of the way it was produced, we could actually then address those in a separate session, or and so this whole piece could begin to grow as new topics are explored throughout the year.
So I'm not an educator, so I won't tell you people how to use it in your own workshops, but I'll comment on how I experienced the workshop from 2 days ago. The fact that we came in completely without any idea what we were going to do, what the parameters were going to be. I was also a beginner with the software. The deadline was very tight. We had to produce the first small prototype, I think at 3 o'clock or so. We had to send it out to the final model at 10 o'clock. The energy that was in the room just really, I think everybody was feeding on that, and and many decisions were made, like, I have to do this now, let's just go for it. And I kind of like that type of atmosphere, because when you think about things too long, you actually might end up with a watered down or sort of a compromise of a good idea. Now it was more like this seems like a good idea, let's just go for it. And I think everybody was very surprised the next day when the models came out and actually saw these impulsive decisions come out in a spectacular way. So for me as a participant, I thought the workshop had everything that I wanted in it. So I say it was great.
Well, just in closing, I'd like to thank again Objet for facilitating this active, integrated, synergistic, synthetic learning opportunity for everyone in the workshop participants, the 17 of us, and of course the workshop leaders. It's been an honor to help to organize this and basically facilitate this kind of convergence. And I think that this could really take root in many different ways. Clearly, I showed the map before about some of the logistics about where this could go. I also see a really fantastic opportunity for this to converge in these mini workshop conferences as they start to go to these different events. You know, so I speculated out 11 events, with ACADIA being the 11th. So between Boston and San Francisco, there's these informational flows that would be great to continue a very active and integrated relationship with Objet as we move forward. But now you can already start to see, as we start to connect the dots across the United States, and it has global implications. And I'd like to just close by thanking everyone, the workshop participants, Objet, ACADIA, ACSA, and the workshop leaders for all of your efforts and time. It was a fantastic experience, and I look forward to the next moment of convergence.
Thank you.
Thanks.